Welcome back. We reached the end of this lecture with these conclusions. The first conclusion is that the noise power generated by devices, either one-port and two-port devices, can be characterized by an equivalent noise temperature, and that this can be done regardless of the origin of the noise. It can be thermal noise or noise generated by other processes that are not thermal. All devices can be the noise produced by all devices present in communication systems can be characterized by noise temperature, particularly the antenna noise, right? And for the case of the antenna noise, it's important to remember that the antenna noise temperature is strongly dependent on frequency, right? It's also dependent on how directive is the antenna, and if the antenna is pointing out to a strong noise source, like the sun, or is pointing out to the sky, where normally we have less noise. And finally, the third conclusion is that in a cascade of two ports, the equivalent noise temperature and gain of the first element is critical. And having a lossy element ahead of a receiver is very detrimental, right? So the first stage of a receiver can severely degrade its noise performance. For example, the cable between the antenna and a receiver, the loss in that cable, it's very critical and can degrade the noise performance of the whole system. So beware of losses ahead of the input of the receiver. If you're interested in this topic, you can look at the references that I list here, which are mostly books and journal articles. You can also look at the standard definitions given by IEEE and the International Telecommunications Union. And finally, I would like to end with a slide with credits to other people and credits to the authors of this material.